Question 3 on here says, how many different 5-card hands are possible if we use a standard 52 card deck? Now again, if you're not familiar with this idea of the breakdown of a standard 52 card deck, you can look at that file that's posted on Canvas. So it talks about how it's all broken down. But the other thing that we haven't talked about yet with when we're talking about questions with cards is this idea of a hand of cards. This idea of a hand of cards is like if you're playing a game with cards and someone deals you a bunch of cards, you just hold them all in a hand of cards. So it's just the group of the cards that you're holding. And if we think about it, when you're holding those cards, it really doesn't matter what order you put the cards in, right? Like I can take these 2 cards and I can swap them in my hand order. I can then move them over here and put them between these ones. I can shuffle those cards up. It really doesn't matter. The only thing that matters is what cards I have. So all that matters is what cards are in the hand. So anytime we see this idea of a hand of cards, we can instead think about the word group. It's essentially what it is. There isn't a sequence to the cards. So there's not oh, this is my first card, this is my second card, my third card, so on and so forth. It's just all of them in a collection. So with that in mind, the idea of it being a group should trigger that idea of using combinations. So let's think about what the group is. So it's a group of, well, in this case, how many? Well, a group of 5. And then from how many? Well, in this case, it just says 5 card hands. It doesn't give any specific type of cards, so we can use anything from the deck. So 5 from 52. When we put that into our formula, we're going to have combinations from 52 things. We're going to choose a group of 5 things. So we need to set up that formula. So then we're going to have 52 factorial on top divided by 5 factorial, and then 52 minus 5 factorial. So let's do that subtraction there. 52 minus 5 is 47. So we have 52 factorial divided by 5 factorial, 47 factorial. Now this is a great example for where that simplification process that we've been doing with these factorials is going to be really useful, because I do not want to write out 52 factorial and 47 factorial. Those would be super long. So instead, let's start to write out 52 factorial. So we'll have 52 times 51 times 50 times 49, and we're thinking about when do I have to stop? Well, notice on the bottom I have a 47 factorial, so we're going to stop with 47 factorial. So let's put all of that over 5 factorial, 47 factorial. Notice I didn't pick the 5, I picked the 47 because it's bigger, so it lets me stop sooner. Now I've got 47 factorial on the top and 47 factorial on the bottom. So we cancel all those numbers. There's a 47, a 46, 45, all the way down to 1. All get canceled out. All we're left with is on the top there's 5 numbers, 52 times 51 times 50 times 49 times 48. And on the bottom is 5 factorial, which is 5 times 4 times 3 times 2 times 1. Now a helpful hint for when you're computing these combinations is notice how many numbers are on the top and the bottom. On the top we've got 1, 2, 3, 4, 5, and on the bottom I've got 1, 2, 3, 4, 5. You should always have the same number of numbers in the 2 spots if you did your simplification correctly. So what we need to do now is those two different multiplications. So let's grab our calculator here. So we need 52 times 51 times 50 times 49 times 48. Nice big number here. So all those together is 311 million. Bring it back up because I don't remember what I said. 875,200. And then we need to do 5 times 4 times 3 times 2 times 1, which is 120. And the last step is to do the division. So 311,875,200 divided by 120. We have 2,589,960. 2,589,960. Which is kind of a really fun result because there's a lot of different games that you play with standard decks of cards that have 5 hands. So this tells you that there are 2.5 million possibilities for the cards that could be in your hand of cards, which is pretty cool.